Today we're going to talk about inverse functions and relations. All right, what's an inverse function? Well, first of all, you have to know the notation. You all know that f of x means a function. Well, f raised to the negative 1 power of x reflects inverse notation. It's the same as reflecting over the line y equals x, which actually means to switch the x and the y values. So basically, when you're finding the inverse, that's what you're doing. You're going to switch the x and the y. Okay, number one, if f of x is that set of points, and every point is an x and a y, they want you to find f negative 1 of x. Okay, pause the video, copy the heading, and number 1, and then come back and we'll finish. All right, now that you have it all copied, let's find the inverse of x. Well, inverse means to switch the x and the y. So if my first point is a negative 5, 2, its inverse is going to be 2, negative 5. If my second point is 8, 3, now the inverse of the second point is going to be 3, 8. And my third point in the original function is 7, 1. Its inverse then is going to become 1, 7. So I just did the inverse of the function of f of x by switching the x and the y. All right, let's go on further and see what else it has to say here. When finding the inverse of an equation, remember f of x always stands for y. That's very important to know that, because what you're going to need to do is replace f of x with y. Switch the x and the y, and then solve for y. So what you're doing is making sure you have a y value in the equation, then you're going to switch your x and y and solve for y again. Get y by itself. All right, copy those steps down in example number 2, and then come back and we'll continue on. All right, now that you have all that copied, let's go on and find the inverse of f of x, which is x plus 1 over 2. Well, in order to find an inverse, I need a y value. And we all know f of x stands for y. So really, this can be rewritten as y equals x plus 1 over 2. So now we're going to go ahead and find the inverse. Inverse means to switch the x and the y. So I have x equals y plus 1 over 2. I'm not done yet, because inverse means to switch the x and y and then solve for y again, which means we've got to get y by itself. All right, so let's solve. The first thing I think we should do is multiply both sides by 2. The 2's cancel here, and I get 2x equals y plus 1. I still don't have y by itself, so I'm going to subtract 1 on both sides. And now I have 2x minus 1 equals y. So the inverse of y equals x plus 1 divided by 2 is 2x minus 1 equals y. That really wasn't too bad. Let's move on to a couple more examples. Example number 3 says f of x equals 3x minus 4. We want to find the inverse of that equation. Well, in order to find an inverse, we need a y value. And we all know f of x stands for y, so we can rewrite it as y equals 3x minus 4. Okay, so now we're going to write the inverse. We're going to switch the x and the y. So we have x equals 3y minus 4. We now need to get y by itself, so we have to solve for y again. So we're going to add 4 to both sides and have x plus 4 equals 3y. We still don't have y by itself, so we're going to divide each side by 3. And we have x plus 4 divided by 3 equals y. Y is by itself now, so there's our inverse. Okay, let's go on to number 4. Find the inverse of y equals x squared plus 3. All right, well, we already have a y there, so we don't have to change anything to y because it's already there. So all we need to do now is switch the x and the y. X equals y squared plus 3. Okay, let's get y by itself. We're going to subtract 3 on both sides and get x minus 3 equals y squared. How do we get rid of squaring? You're right, we're going to square root both sides. But remember, you drew the square root symbol. So on the right, squaring and square root cancel each other out. But on the left, we're going to get plus or minus the square root of x minus 3. Since I can't simplify that radical anymore, there's my inverse. Okay, let's move on. Verifying inverses. Pause the video, take a couple minutes, write everything you see down here, and then come back and we'll review what you've written and then go to example number 1. Okay, now that you have everything written down, let's go through what you wrote. Verifying inverses. You can determine whether two functions are inverses by finding both of their compositions. If both compositions equal the identity function, then the functions are considered to be inverse functions. A function is one-to-one when f of x and its inverse f negative 1 of x are both considered functions. For example, if f of g of x is x and g of f of x also equals x, they are considered to be inverses of each other. Alright, with that being said, let's determine whether each pair of functions are inverse functions and explain your reasoning. Alright, now that we know we can use function or compositions to determine this, we're going to go ahead and do that. In order to prove that g of x and f of x are inverses of each other, we're going to need to find f of g of x and then find g of f of x. And if our answers are exactly the same, then those two functions are considered to be inverses of each other. Okay, with that being said, let's do the one on the left. We need to find f of g of x. So first of all, we need g of x. Well, g of x is nothing more than 1/3 x minus 3. So that now I know what g of x is, I'm going to find f of 1/3 x minus 3. So that'll be 3 times 1/3 x minus 3 plus 9. Okay, we're going to do distributive property. 3 times a third is 1. So 1 times x is just x. 3 times a negative 3 is a negative 9 plus 9. A negative 9 and a positive 9 cancel each other out. So I end up with plain old x. So f of g of x is x. Okay, let's find g of f of x. All right. Working right to left, we find f of x to be nothing more than 3x plus 9. So now g of 3x plus 9 is going to be 1/3 of 3x plus 9 minus 3. Okay, let's do some distributive property. 1/3 times 3x is 1x, which is x. 1/3 of a positive 9 is plus 3 minus 3. 3 minus 3 cancel each other out, so I end up with x. Both compositions came out to be x's, so we can say yes, they're inverses. All right, let's see if we can prove another pair to be inverses. For number 2, we have f of x equals 4x squared, and g of x to be 2 times the square root of x. All right, let's prove that those two functions are inverses. So we're going to need to find f of g of x, and then we're going to need to find g of f of x. So we need to find each composition. All right, let's move to the guy on the left. Working right to left, we're going to find g of x first to be 2 radical x. So then f of 2 radical x is going to be 4 times 2 radical x, the whole thing squared. Well, 4 times 2 squared is 4, and squaring and square root cancel each other out, so that I get 4x. And 4 times 4x is 16x. So again, if you don't understand what I did with that squaring and square root, think of it this way. 2 radical x squared is nothing more than 2 radical x times 2 radical x, which really is 4 radical x squared. Squaring and square root cancel each other out, so you get 4x. Okay? So that's how I changed 2 radical x, the whole thing squared, to be 4x. All right, with that being said, f of g of x is 16x. Okay. Let's find out now what g of f of x is. Well, f of x is 4x squared. So therefore, g of 4x squared is going to be 2 square root of 4x squared. All right. Square root of 4 is 2. Square root of x squared is x. So we get 2 times x, which is 4x. Do the compositions have the same answer? No, they are not. So in this case, f of x and g of x are not inverses. So today we did a lot. We actually learned how to write an inverse, how to solve for an inverse, and then how to prove functions are inverses. We'll go over this again in class tomorrow. If you have any questions, please write them down and bring them to class with you.